Cool. Welcome to the State of Open Source Serverless in this talk, where I'm going to talk about how we can deal with serverless, use serverless, deploy serverless using open source tools. So I'm Jonatas. People call me Jojo. I'm a cloud native engineer at Container Solutions. You can find me on GitHub or Twitter on Jonatas Baldin. That's my handler. And occasionally I'm doing some live stream coding and serverless and Golang, some Python at twitch.tv/deploy every day. And also, as a heads up, there's going to be a lot of tools and a lot of platforms and a lot of names in this talk. And so at the end, I have a link that you can click and see all the resources that I do to make the talk. So if you want to like deep dive and explore around, you can go on that link. So you don't need to keep a lot of notes about tools and stuff. So you can just go in the end. All right, so gladly this topic was already covered today. So what is serverless, right? So serverless is this thing that's meant too many things, and now it's almost losing its meaning in the end, right? And technically for me, I think these are the 4 pillars of a serverless platform. You don't want to worry about server management anymore. You just want to write a little bit of code, put it somewhere, or use a third-party service. You don't want to worry about this. You don't want to worry about scalability. If you have 10 users today, and if you have 100 users tomorrow, 1,000 users next week, you want to go to sleep without thinking about if your code is going to scale or not. You only want to pay for what you use, so no wider resources anywhere. So if your system is not being used for anything, you don't want to pay for that. And it's also an event-driven system. So all the components in your architecture, they react to each other. They can send messages, they can trigger functions, they can trigger by files being uploaded somewhere and users being authenticated and lines being inserted in databases. So you can have all these events happening in your system and things being executed and triggered by these events. But from a more business perspective, from a more experienced perspective, I like this term noiseless. So I think in the end, it doesn't matter how we achieve serverless. I think what we wanted, okay, I think the chat is bumping on my screen, but yeah, don't worry about it. I think one thing we want to achieve with serverless is to reduce noise. We want to reduce noise in development, in infrastructure, in the technology that we use. We want to focus on the business of being, we want to create, we want to innovate. We want to stop worrying about deploying nginx servers and like RabbitMQ clusters and all these things. That it's nice, it's amazing technology, that it's nice to know how to do these hard things, but we could use this time to solve real problems. So I think serverless, doesn't matter how the technicality work. I think that the main idea is to reduce all the noise in technology that we have today. And it all started with function as a service, right? FAASD, with AWS Lambda 2014. So they did this thing that works basically like this. You write a little bit of code, you package it up, usually like in a zip file, you send it to the cloud. In the cloud, you say subcloud, when there's a request on this specific endpoint, can you just execute this piece of code I gave to you? And the cloud's like, yeah, sure. And it executes your code. So this was like mainly what was happening. And this trigger that in this example was a request, could be a file being uploaded to a bucket, could be a message in a queue, could be a lot of things, right? So we have this reactivity with these triggers incorporated into the cloud provider platform. But serverless is way more than just function as a service. We have buckets, we have like queues, we have API gateways, we have all these different things interacting with each other. And that's like a serverless architecture, how a serverless application works. And when you talk about big cloud providers, and then you get Google Functions, or you get AWS S3, or Azure Queues, or AWS API Gateway. So we have all these implementations from these components from the main cloud providers all the time. But what about open source? How can make this open source? So the quick recipe, you get all of these things, you put into Kubernetes and then you code. So if you install anything in Kubernetes today, you're good to go, right? Kind of like that, almost like that, you're gonna get to Kubernetes soon. But the main thing about open source serverless is that I think that open source is amazing, right? I know that my job depends on open source. I know that most of your jobs depend on open source. That the way we deal with technology today, how we advance so fast in technology, it depends on open source. So I think it's nice that you can put some light into that as well, because most of the fast platforms today, the serverless platforms, they are done and created and used by big cloud providers. And there's no problem with that. But I think we also we should, and we have opportunities to think about serverless in an open source way. And we can start at this little place here. So this is our starting point in this adventure. This is the Cloud Native Computing Foundation Serverless Landscape, so the CNCF. So the CNCF is this organization that deals with cloud native technologies, and they have this landscape thing with all the projects that they approve. They're like on their sandboxes and things like that. And we have the serverless one. So we have this specific one. So this is a starting point if you wanna go and find out what is about open source serverless all about. First of all, and we are going to focus on these installable platforms. So this section down here, it means mostly fast platforms. So function as a service platforms that you can host yourself. There are other things in this bucket as well, like tools that help these platforms to exist, but mostly are the platforms themselves. And that's where we're going to focus today. Also, the same organization, the CNCF, they did a survey last year about the adoption of cloud native technologies from 2018 to 2019. So this is a comparison. And under the serverless parts of this survey, we saw that people are indeed using more serverless. On the left side, we see the hosted platforms. So this is like AWS Lambdas and Google Cloud Functions. But also we see an increase in installable software. So people are using more open source solutions. So it's a nice thing that this is happening, and we can see there's like some markets and some user base for that. And these are the installable serverless platforms. So their usage on this survey as well. So you have Knative, OpenFast, Kubernetes, Virtual Kubernetes, leading, and a bunch of others. So you can see that there is markets, there are different tools, they behave differently, they're built differently, and it's nice that you can explore them, you can use them, you can test them out. And we have all these platforms, and they're open source. Do they have a common ground? Do they share something that most or all of them uses? And yes, there are a couple. First of all, we have containers as functions. And yes, container became functions in these platforms. Docker is widely used across all the industries. It's a nice and easy way to package software and put it to run somewhere. It's very portable. And it's very good at run a little bit and die, right? So that's what we want from our functions. We want them to run and then to scale down to 0. And containers are very good at that. And the Dockerfile became the new zip file. So instead of zip it up with a zip, you use a Dockerfile. In the end, if you take away all the metadata from a Dockerfile, it's actually a tar. It's actually a compressed collection of files. So it makes a lot of sense to use that as the way we package the software today. And one interesting thing about containers is their visibility to the end user. Most of the platforms, if not all, uses container in the background, but the way you see it is differently. For example, Knative, you actually build and give the platform a container. So you need to be aware on how Docker works. You need to be aware on how to build and ship these images. But in other platforms like OpenWhisk, you actually just write a little bit of code as you do with a Google Cloud Functions. And the platform is going to build the containers for you and is going to deploy and manage the containers. It is way more invisible to the end user. So we have this spectrum on how containers are treated in these platforms. But once you have a shitload of containers, then it becomes hard to manage, right? And then you need a tool to manage containers. And then, of course, you need Kubernetes. And Kubernetes is everywhere today. I love the tool. I really enjoy it. I work with it. But it's funny how it just took over all the things related to containers nowadays. And as Mr. Hightower said in 2018, Kubernetes is a platform to build platforms. It is far from the end game. And the people from the serverless community took that by rule. We're building platforms or using a platform to build other platforms. And this is very, very cool. So we have Kubernetes as a foundation in a way. And why? Well, Kubernetes has a lot of nice things. You can manage containers. You can restart the containers when they fail. It's a very good at self-healing system, at maintaining system at specific state. It's very good at self-healing. It's very good at scalability. It's very good to understand that there's nothing running and then scale things back and forth. It's very, very much extensible. So you can write your own ways of interacting with the Kubernetes resources and your own ways to deal with Kubernetes. So with that extensibility, we can think about how we can use Kubernetes and make it better for in a serverless perspective. And also Kubernetes is everywhere. There's a lot of knowledge, there's a lot of content, there's a lot of courses, there's certifications, there's so many things that if you understand a little bit of Kubernetes already, it makes way easier to understand these platforms if you use Kubernetes on the background. So it makes sense to use it. It's a defined industry tool, so why not? And with the Kubernetes comes its ecosystem. So we have a lot of tools that interact very, very well with Kubernetes for metrics, for logging, for managing networking, for queues. And if they're like not only made for Kubernetes, like external DNS for Kubernetes to manage DNS entries, which is quite cool. So using Kubernetes allow us to have the entire ecosystem and their communities and their developers and their way of thinking. So you bring all this package and you put this layer on the below your platform and you can build on top of that. Also, these main platforms, they usually segregate the way they deal with workloads. So we have HTTP workloads, so synchronous HTTP requests, stuff like that. And we also have eventing. So it's more like an asynchronous kind of thing, using queues, using messages. And the platforms usually differentiate how you interact with the platform in these two different types. Let me just add some water. All right. And the developer experience to use these platforms, it's usually through a CLI and dashboard. So basically all of them, they have CLIs. So you can like type commands and do things. And some of them have dashboards where you can click places and do things. But it's very good for experimentation and trying. But once you want to have a more, I think, more production approach, you want to have the functions and their configuration in a source code format. You want to have a YAML, for example. So most of them, they have like a YAML spec to define and deploy these functions, or they even have like Kubernetes custom resource definitions. So they extend Kubernetes to understand functions, to understand the serverless concepts. So you don't need like a middle tool. You just talk directly to Kubernetes because the platform itself understands what a function is. And a very quick note about server management. I know serverless is all about not having to worry about the servers and everything. And I'm talking here about Kubernetes and whatever, and let's deploy Kubernetes. And that's probably means servers, right? And yes, that means servers running. But in an open source serverless platform, I think that's usually two different target groups, target users. We're gonna have the platform team responsible for up and running, maintenance, and all those operational part of a serverless platform. And we have the development team, the end users, the people that are gonna write the functions and use the platform. And for the end users, the infrastructure should be invisible as it is in AWS Lambda, for example. Someone in Amazon, some team, some group of people are running those servers that we are using. They're just invisible to us. So I would say that's today we're going to focus on the development team, the end users. So if anyone says like, yeah, but there's servers in this solutions, yes, they are, but they should not be responsible for the users to manage the servers. And yes, so let's go on some platforms. Let's see how they work. Let's see how they behave. One thing about the platforms here is I picked like 5 of them to give a little bit more of a highlight. All of these platforms, they deserve their own talk. They deserve their own 40-minute talk in a meetup. And they have. So if you go to YouTube and type these names, you're gonna find like full-length talks because they're big, they're complex, they're amazing. And yeah, it is not like 5 minutes that's gonna make you understand and use them. but I want to give you like a quick taste so you can test around. And I picked the ones that I'm talking about today based on their development activity. So if they're being active development or not, their community, how active are the community around these platforms, and also their highlights. So things that make them different than the other platforms. So we're gonna talk a little bit about some, and you're gonna understand how things work more or less in this realm. So first of all, OpenFaaS. So I was able to contribute a little bit to OpenFaaS last year. It was a very, very nice experience. So let's start with that. So it is not strictly tied to Kubernetes. Of course, you can run in Kubernetes, and if you're in production, you should run in Kubernetes, but you can also run in Swarm, and you can also run in a thing called faasd, which uses containerd directly. So there is no Kubernetes and actually no Docker if you don't want to. So this is a different way to deploy a serverless platform, and it's very, very new. So this is one nice thing about OpenFaaS. This is how OpenFaaS usually works from an interactional point of view. So a user or an application would use a CLI, UI, or a REST API to talk to this gateway, and this OpenFaaS gateway, this piece of this component, will talk to fastnets, which mainly manage the things like the containers and the functions. So it makes sure that the functions are running. You can invoke these functions, all these things. If you want to do some async invocations, then it's going to use nets streaming to kill the invocations. And one thing that I really enjoy about OpenFaaS is how it does scalability. So for example, there is a metric on Prometheus, like requests per second. And if this metric exceeds the threshold, then OpenFaaS scales up and down the containers. So it's a very nice way to do scalability using a tool that's it's already well-defined for metricing and alerting in our industry today. Also, the OpenFaaS function store. So once you install OpenFaaS, you're presented with this dashboard where you can click and install a function. So it's a very nice way to start up and running and to see how the platform works. From a community point of view, there's the OpenFaaS incubator. So this is a GitHub organization with this project. So if you have like an idea to extend OpenFaaS or to make it better, you can use this incubator, put your project there. You're gonna get some visibility from the community, some help from the community. And if your project is very nice and very stable, some point in time, you might get merged upstream to the official OpenFaaS platform. And this is like a hello world. So once you have the platform up and running with two commands, with actually one command, with fast CLI, you can deploy a function from the store and you can invoke it with the same command. So once everything is set up from the developer point of view, that's how we do it, like, so we can start playing, we can start messing up with. Let's talk about Knative. So Knative is a project from Google, and the mentality here is bring your own container. So you actually write your function, you write your codes, you put in a container, and you ship the whole container to Knative. And it works by having two models of execution. We have serving and eventing. So serving, you need to expose a web server on port 880. So that's the contract. It doesn't matter the language you use, the framework that you use. If you put some code in a container, exposing a web server on port 8080, it's gonna work. So this is a very nice, it's, you don't have the facility of having a defined handler, but you can run whatever you want. And they will have the eventing part. So if you listen to CloudEvents, if you know how CloudEvents works, if your code knows how CloudEvent works, you can receive events inside Knative. Another highlight that eventing system is 100% CloudEvents. So CloudEvents is this spec that tries to create common data to describe events, right? So on AWS and on Google, on Azure, every time you receive an event in a function, they have a different metadata. They look different, they JSON are different. And this CloudEvents spec is trying to make that, make a pattern, make a specification out of that. So everything that happens in Knative with eventing is with CloudEvents, which is quite cool. And somehow, some way or another, Knative is run inside Google, Red Hat, IBM, Pivotal, Trigger Mesh. So you can see it's a tool, it's a platform that it's being used in all these big cloud providers and technology companies. So it is very nice that they are somehow using it or extending it or make some use of Knative. And again, a simple hello world. Once you have the system up and running, you just give it an image. In this case, it's a hello world in Go. And if it again exposes a web server on port 8080, you're gonna have this external URL, you curl it, and you're good to go. Let's move a little bit to Apache OpenWhisk. So this one powers IBM Cloud Functions. So also being used by a big technology cloud provider. This is its architecture, a very simplified view of the architecture. It kind of looks like OpenFast, so you have a controller, and this controller is going to be responsible to invoke and creating and managing these functions. One nice thing about it is that the controller is written in Scala. So in the cloud native Kubernetes world, usually things are written in Golang, and this one is written in Scala, which I think is pretty nice to have a little bit more color and flavor in these functions. One thing I like about OpenWhisk, it hides Kubernetes very well. So from a user perspective, you barely see Kubernetes. You don't see Kubernetes. You don't see containers. You don't see these things. You write your function, you give it to OpenWhisk, and it's going to make sure it runs. There's no custom resources. There's no kubectl Kubernetes-like experience. So there is maybe a good thing that we don't force the users to understand Kubernetes if you hide it, or even understand Docker, for example, if you hide it very, very well from them. So there's this unique spec on how you interact. So you write some YAML. There's like concepts of packages and actions and functions. You put up together some YAML. You write a function, again, a normal JavaScript function with some parameters, and you deploy that manifest, and you're able to invoke the function. So again, 2 commands. We can see that these platforms, once they're deployed, once they're up and running, it's quite easy to use them. Another thing on OpenWhisk, they have this thing called Composer, which I really, really enjoy the concept of it. So once you deploy your functions around, you can use this JavaScript tool to orchestrate and compose functions. So in this example, we have this sequence of functions. So you give it an input, and the output goes to another one. So we're actually building a sequence on top of already deployed functions. So this is like a programmatic way to access your functions inside the cluster, which is quite cool. It's like a step functions in AWS. So I love these ideas. I love giving developers these new perspectives and new ways of interacting with the platform. So OpenWhisk did it with Composer. And there's a book. I love books. I think books about technologies, they usually deep dive in the platforms, and they tell little tips and tricks and history and how things work, why things work. And in the open source serverless, you don't have too many of them. And OpenWhisk has one, and I really enjoy. And I think once you have more stability in this realm, when things settle down a little bit more, once these platforms stopping growing so fast, I think we might see more books and more content like this. Almost there with the platform. So now we have Riff. Riff powers the pivotal function service. So it is in alpha right now. You can find their service in Google, register to try it out. One thing that I like about Riff is that it actually uses Knative on the background. So I have this tool actually using another serverless tool as part of it. So you can see like this mesh up together, this reusability that we are already seeing in the open source serverless world. And the way they build their functions is with cloud native Buildpacks. So instead of giving a container, you give it a piece of code. You run this command with like a repository with some code in some specific formats that they want you to write. And then this happens. And when I see this GIF here, I think about Heroku a lot. Like it feels like Heroku when I do like Heroku deploy, whatever. And that's because Buildpacks, the tool being used to do this build, is actually made by Heroku originally. So this platform went like, hey, how can you actually make containers invisible to our users? They build a build tool. So they use this build tool to create these containers and to deploy them. So again, building on top of giants, and it's a very, very pleasant and nice way to see how functions are built and deployed with Riff. And the last one that I picked for this like more kind of highlights is Nucleo. So it is focused on data science pipelines, and it has very, very nice access to GPU. So it's just a flag, you click a button, you can have access to GPU. And for me, it was the easiest one to get up and running. It's like this. This is the only command you need to type to get this platform up and running. It runs in a Docker container in your local machine, and you're presented with this just dashboard that I'm seeing around for the serverless platforms. So with the dashboards, you can create functions, you can configure the way they trigger it, you can write the code inline, and you also have this Postman vibes on the right, where you can invoke your function and test your functions. So I really, really enjoy how Nucleo did their dashboard and how easy it is to get this dashboard up and running. And this is also another way to give developers a different experience using platforms. So Jupyter is this Python tool that usually data science people use to write their code. So you can write like code in the cells and execute them independently of each other. You can plot graphs, you can write Markdown. So data science people loves it, and it's an amazing piece of tool. And what Nucleo did is they developed a plugin for Jupyter to define, deploy, and execute serverless functions from a Jupyter notebook. So as a data science person, I write this function and I give it an input, and it's gonna run somewhere else. But I never need to leave this interface, which is quite cool as well. And I'm just gonna give now a quick, very, very quick shout outs for other tools that didn't make here. So I have Kubeless, FN, Fission, also fast platforms, work like a charm. We have Azure Functions, and I know this is gonna be the only proprietary solution here, right? So the thing is with Azure Functions is the runtime, the thing that runs your function in Azure Functions is a Docker container, and it is open source. So if it is Docker and open source, you can run in Kubernetes, right? And yes, and they actually, in their official CLI, they give you an option called Kubernetes deploy. So when you write a function, you can deploy it to Azure or deploy the same function to Kubernetes. So thank you, Azure, for like doing this thing. It's just amazing how we can use the same tool both ways, in the proprietary and an open source solution. We have Keda. So Keda is it's an outscaler for Kubernetes. So on Kubernetes, when you need to scale up and down, you usually use metrics like CPU and memory. And Keda brings a different type of metric, brings the eventing metric. So with this outscaling, you can scale up and down your functions using events. So you can watch a queue, and if there's no events in the queue, everything goes to 0. And if there are events, you can bring more workers, more functions to react to these events. So that's a very nice way to, it's an open source serverless tool, not a platform. And this is the one that I understand the least, all these names and icons in my screen now. But I know that KF serving uses Knative and Kubeflow and all of these things to present data science models to the internet. So people like make their models, I don't know, data science, machine learning stuff. And KF serving makes it very easy to expose these models to the internet. So adds endpoints so people can actually use these models and test them out on the internet. So that's all it does. But man, I don't know how to dive deep in this one. Too much for me. And Trigger Mesh did a thing called Lambda, Knative Lambda runtime. So you can run Lambda functions inside Knative, inside Kubernetes. And with that, you can understand that in open source serverless is a wild, wild world, and you can do whatever you want. So this kind of solution, like they make me very, very excited that we can do all sorts of stuff. And last but not least, I would like to talk about the CNCF, Serverless Working Group. So a bunch of people got together to talk about what serverless means in the cloud native open source space. And they come up with some products. So they have the white paper. It's a very beautiful written white paper about serverless concepts and architectures and how we should think about serverless in an open source way, which is very, very nice to read. They did the serverless landscape. So the thing that I showed before, also they were the ones that made it. Also the CloudEvents that I talked before, that little spec to make events the same way different platforms, they did it. And this CloudEvents also has SDKs implementation like Python, Go, Java, and all the major active languages. It's very, very cool. And they also have this spec very in the initial states about serverless workflow. So how can we orchestrate functions that talk to each other, how we can compose these functions, what it should look like. So this specification is working on that. So all of this thanks to the serverless working group in the CNCF organization. So if you want to take a look, they're very amazing people. And to finish it up, why should you care about all of this? After you saw someone with like some parrots on the background talking about open source serverless, why you should really care about it? And first of all, open source. Open source is amazing. You can create things, collaborate, communities, you can fork it, you can remix it, you can extend it. You can do so many things with open source. With our jobs depend on open source. A lot of things today depends on open source. And I think it's quite unfair that we put this way of developing software today called serverless in the hands of all the big cloud providers. I think there is space for open source tools to rise and shine in this world. So I think that's alone is already amazing. But you have other things like leveraging the Kubernetes ecosystem. So we're already using a well-defined tool in the industry in all its ecosystem to build these platforms. Observability is also big. Now we can see things. It's not this black box anymore that you put our code and it runs. We can see how it runs. We can see the runtimes. We can see, anyway, if you have access to the source code, you can see everything on what's happening in your platform. It becomes more predictable and more easy to find bugs and to debug and to play around with. Kind of have like this avoid locking in quotes, because avoiding locking is the hardest thing you can do in technology today. It's very easy to get trapped in a cloud provider. But if you're serverless platforms, if you're a faasd platform, it's on top of Kubernetes, for example. So you can deploy it in any cloud provider. So at least you can move from one cloud to another with more ease. A limited resource consumption. So on AWS, Azure, Google, you're gonna have an amount of CPU and RAM that you can use. And now with these platforms, most of them, you can just like say, use whatever you want. And you can do whatever you want to your Kubernetes cluster. And as long as you have resources you can use. So this enables us to have different workloads, since we can use way more resources than we have in our cloud provider today. And in the end, fine-tune scalability is nice. We can define like concurrent requests. You can play around with code start times. You can disable code start. In most of these platforms, you can say, hey, in this specific function, I want one to be warm all the time, running all the time. It's just a container running somewhere, waiting for traffic. So you can disable code start. You can just fine tune, turn these knobs on things that with cloud providers, you're not able to. But of course, there's like things that I believe will be better. They're just not better because this is just the beginning. Maturity is a topic discussed across serverless, being closed source or open source. It's just the beginning. There's still a lot of tools to come up, still a lot of patterns, a lot of way with dealing and developing and creating these tools. So I think we need more maturity in the open source as well. And this is gonna come with more people using these platforms being deployed in different places. So I think that's just a matter of time. And also learning content. So I want to see more Stack Overflow questions and answers. I want to see books. I want to see more articles and videos and workshops, courses and meetups and conferences. So I think we still want to see like an Open FastConf and like a Knative Conf. That would be amazing. So once you have more learning content, we're going to attract more people to use this platform, which is going to generate more learning content. So I think educational, it's a thing that we should focus a lot on this platform. And like server management, right? No way. Someone's going to need to manage the service. Fortunately or unfortunately, you. If you work in a platform team, it's probably going to be you managing this. But if you are a user, if you are a developer, you should not worry about serverless. Being AWS, being Knative OpenFaaS, you should not worry about that. That should be transparent to you. And that's That's it for today. That's the State of Open Source Serverless 2020 edition. I hope I can give this talk next year somewhere with a lot of different things, different platforms, more books, more content, more tools, and see what evolves with time in this realm. I'd like to say thanks for everyone to listening up, especially to these people listed here. They helped me with the talk. I interviewed some of them developers from these platforms I just described, and I interviewed them and they helped me a lot, giving very useful information. This link, you can find the resources from this talk. This link up, down, I don't know where the screen is, if you actually see my face right now. So you can find this, the resources, so go there, check it out. And also follow me on the internet at Jonatas Baldin. And that's it. Thank you very, very much.